Hello dear, welcome back again to study physics. Now we'll stop it here in this topic. Guys, Young modulus. Young modulus, we have a rule. But first, what's the symbol of Young modulus? It's measured by E. It's written by E. This is symbol of Young modulus E. But even the previous chapter we studied energy 2. It's written by E. But so Young modulus to both of them. So Young modulus, the symbol is E. Guys, you have a rule. Young modulus E is equal to Young modulus is equal to stress over ratio of the stress over strain. Guys, this is proving. We have to prove to get this result. According to the Young modulus, we can get another formula. Look how. I'm gonna write proved in here. Okay, we know E equal to Young modulus equal to the rule of Young modulus stress Young modulus stress over strain. And as we know, even we studied this is stress. We studied the rule of stress equal to what? Stress equal to tension over area, and strain, you know, elongation over L minus L naught. Guys, just arrange it this fraction. We can just arrange it. This area is move it down, and this L naught move it up. So it's gonna be what? Write T again. This area because comes down, the area comes here, and write L minus L naught inside the bracket, and this L naught goes up. Okay, L naught. So at the end, we've got another rule, new rule, TL naught over AL minus L naught, that rule. So that rule important we have in calculation. So to find Young modulus, we can use this rule. So guys, I'm gonna repeat again. Look, Young modulus equal to stress over strain. Stress, and we know stress equal to tension over area, and strain is equal to L minus L naught over L naught. So now in here we can arrange this. In this step we can arrange it. Move this L naught up and bring this H down. We can bring areas down. So the area bring it down it comes next to the L minus L naught. Look in here. And the L minus L naught move it up. It's become TL naught. So this one is proving, even in certain prove that the equation or the rule of Young modulus. Baba, let me make it nice again. Young modulus equal to stress over strain. Stress, we know stress equal to tension over area, and strain L minus L naught over L naught. Bring this area to down and move the L naught up, equal. Write T, do not touch T. This L naught, it comes up, it comes next to next to tension T. But this area, that one is this L naught move it up, it's become L naught off, L naught up. This area is bring it down, area, make a bracket, don't touch L minus L naught. Okay, so this definition of Young modulus is the ratio stress to strain by the rule. Look, the ratio stress to strain is the relation between stress to strain. Okay. Look, Baba, Young modulus equal to stress over strain. So is the relation between stress to strain. What is the unit of Young modulus? And as we know, guys, to know the unit of Young modulus, we can get the benefit from the last equation, the last rule, this one. We know the unit of T equal to tension. It's measured by Newton. because tension T is 4 is measured by Newton. And we know the unit of length, L naught, its initial length, is measured by meter. And we know the unit of area is meter square. And we know the length of the unit of L minus L naught together as a meter 2. And guys, look, equal T L naught area L minus L. Look at this rule I wrote in here. T tension is measured by Newton. L naught it's measured by meter. Area it's meter square. L minus L naught it's meter. So in here, guys, look, this meter with this meter is gonna be cancelled. So just Newton over meter squared is left. That's why the rule of Young modulus it's Newton per meter square. And this is strain. We studied the rule of strain as L minus L naught over L naught. So it's the relation between elongation to initial length, يعني L naught. Okay, guys, we have now some examples, important, really important. So be with me. Look, a steel of wire, a diameter. We have a wire. The diameter of the wire, diameter is measured by D is equal to 0.40 millimeter. And initial length, يعني L naught equal to 2 meter. Suspended vertically from a fixed point and a weight of 80 Newton. Guys, Newton or weight is يعني tension. Tension equal to 80 Newton. Connected to its lower end. The resulting elongation. So that one, elongation, it means L minus L naught. Calculate Young modulus, find E. Guys, now we proved the rule of Young modulus. Calculate or determine or find E, Young modulus. Young modulus E equal to T L naught over area L minus L naught. This is the rule. Okay. Yeah. And we know T tension is equal to 80 Newton times L naught. L naught we have it's 2 meter. And elongation L minus L naught we have is 6.4 millimeter. But guys, because the length is by meter, look by meter, and the elongation is by millimeter, different unit, you have to make it same. So to convert a millimeter to meter, we have to multiply by 6.4 times 10 power negative 3 meter. We have to make it meter because millimeter by multiplying 10 power negative 3 times area it's left, but we don't have area. There is no area. Hey guys, look, let me tell you something, Baba. But it's written diameter, guys, because a wire, look, if you have a wire, at the end of each wire we have a cross-section area. This cross-section area is like a circle, so we have to instead of area we have to write area of the circle. So area of the circle is equal to pi r square, pi r power 2. Okay, but in the question it's written diameter, so you have to make this diameter to radius by dividing by 2. How we can make this diameter to radius? Because in this rule we have a radius, divide by 2. Okay, so it's 0.40 divide 2 is become 0.20 millimeter. Again, this is millimeter, you have to make it meter, multiply by 10 power negative 3, and 0.20 times 10 power negative 3 meter. This is equal to our radius. Guys, because the questions gave us the questions given diameter, not radius. So diameter is equal to 0.40 millimeter. Look, first you have to make this diameter to radius by dividing by 2. 0.40 divided by 2 is become 0.20 millimeter. Now this is radius because we divide by 2. But it's millimeter, you have to make it meter by times 10 power negative 3 meter. So we have radius Now radius is equal to 0.20 times 10 power negative 3. Radius radius 0.20 times 10 power negative 3 meter, all power 2, because the r is square power 2, and we know the value of pi is 3.14. So guys, but let me make it nice. Wait, I have to write in here, is better. Look, the area we said is pi r square, so the pi is 3.14 times r square. This is r square, we divide by 2 diameter. The answer is 0.20 times 10 power negative 3 power 2, because r is square, times elongation, we know is 6.4 times 10 power wait 6.4 times 10 power negative 3. So look, Baba, this is the area. Area pi r power 2. This is the area. Pi is 3.14. The r power 2, we have got the value of r by dividing diameter by 2. So this is r, and times elongation. Elongation is 6.4 times 10 power negative 3. And we know in the up we have 18 times 2. So you can use calculator, and you can get the answer easily. Just use calculator, but be careful of the unit. So the last answer, Young modulus equal to 2 times 10 power 11 Pascal. The unit of Young modulus, Pascal, PA. Okay, guys, another question we have. Question 1. A metallic wire, a diameter, again diameter we have D equal to 1 millimeter, and a length L equal to 2.3. It's made of the copper. The Young modulus E, it's written. Okay, part A. Calculate the cross section of the area of the wire. Part A answer. Calculate the cross section area. We said the wire at the end we have two cross sections, so we have to find the area. Area rule is equal to pi r square. Okay, find area just. So we know the value of pi is 3.14 times, make a bracket. But again, we don't have a radius, but we have a diameter. Again, same thing like the previous question. We have a diameter. So first we have to make the diameter to radius, then put the value in here, because Baba, the rule is written by radius, but the question is given us by diameter. So diameter is 1 millimeter. How to make it radius? Divide by 2. This becomes 0.5 millimeter. So to make a diameter to radius, divide by 2. So this is now the value of radius. But guys, against millimeter, make it meter, convert to meter by multiplying 0.5 times 10 power negative 3 meter. So this is radius, because we divide by 2 and we convert to meter. This is the value of radius. Put the value of radius in here, 0.5 times 10 power negative 3 power 2. Guys, the value of radius, this is the value of radius, and you have to square it. How we know the answer is equal to 0.5? The first expression is given by 1 millimeter just. It's diameter, but the rule is radius. So convert the diameter to radius. How? Divided by 2. So 1 divided by 2 is 0.5. But it's millimeter, convert to meter by multiply by 10 power negative 3. Okay. So use calculator first. Use calculator first. Do the power, then multiply at the end. So the value of area, the last answer is 7.85 times 10 power -7. The unit is meter square because the unit of area. So part A, we will use this rule, pi r square. We know pi is 3.14 and r its radius. Convert the diameter to radius. This is the answer, and just put it in here. You get the answer easily. Part B, easy part B. Part B. Okay, part B. يلا. Calculate the strain of the wire for an elongation is 0.85 millimeter. Strain. What was the rule of strain? This is strain simple. Strain equal to L minus L naught over L naught. يعني elongation over initial length. In here it's written elongation equal to 0.85. So directly write 0.85 millimeter. It's millimeter. And where is L naught? L naught is L naught. It's written length 2.3. This L naught 2.3 millimeter. Sorry, 2.3 meter. That one it's 2.3 meter. Guys, that one again, the zero elongation is written by the unit. It's written by millimeter, but the length is by meter, so it's not allowed. It's not impossible because it's different unit. The elongation millimeter, you have to make it meter again, multiply by, to convert millimeter to meter all time multiply by 10 power -3 to be meter. Now it's both it's meter, so meter will be cancelled. So divide just 0.85 times 10 power -3 divide by 2.3. The answer is strain equal to 3.7 times 10 power -4 without any unit, because we studied strain is unitless because both of the units will be cancelled. So guys, you'll be use this rule, part B, find strain. We have elongation, and you have length too. Just be careful of the unit. In exercise number 1, question 2, in exercise number 1, calculate the stress of the wire and the force is needed. Okay, how to calculate the stress? This according is you have to get the benefit from the previous part. That's one. Question 1. Okay, calculate the stress of the wire. How we can find stress? And we know the rule of stress. First, calculate the stress of the wire. Guys, look. The rule of Young modulus is equal to stress over strain. According to this rule, we can find stress. Young modulus equal to stress over strain. We can easily find stress. Okay, I want to find this stress. So stress equal to what? Multiply Young modulus and strain together. Young modulus times strain. Okay. So guys, the previous part, it was written Young modulus. Young modulus 1.1 times 10 power 11. So write instead of the Young modulus 1.1 times 10 power 11 Pascal times. Even strain, we've got the answer. The previous part, strain 3.7 times 10 power -4. 3.7 times 10 power -4. Multiply together, you get the Young modulus, and the Young modulus is equal to 4.07 times 10 power 7, and the unit. Wait a minute. The answer 4.07 times 10 power 7. The unit of Young modulus is Newton per meter square. Okay, so we can get the stress. We did the first part. We have find stress in here, multiply Young modulus by strain. We have Young modulus the previous part, and we got the answer of strain 2. Just multiply. Now the question said I'm even find the force too. Let me erase it, that one. This question. Find tension 2. Force, it means tension in this topic. So we have a rules. Stress equal to tension over area. Find tension. Tension equal to multiply this one by this one. Stress times area. Okay, find tension. So we have stress. Because we get the answer of stress in the previous part. So stress is equal to 4.07 times 10 power 7 times, and even we have got the area too. The question one, it was 7.85 times 10 power negative 7. So the last answer is 31. Multiplied by calculator, the answer is 31.9 Newton. Okay. I hope to understand, guys, all. Just you should memorize the rule and all become easy. Guys, we have section 2 to review. I have another some examples. Question 1. What is the strain of the wire of the length, this initial length, equal to 0.4 and compressed by 0.05? Guys, in here it said find strain. So the rule of strain we know. L minus L naught over L naught. But in here we don't know which one is L, which one is elongation, because it isn't written, like it's not written. How we know which one of them is elongation and which one of them is L naught? Guys, because in here it's written compressed, because you have compressed, that mean the numbers come after the compressed. That one it's mean L minus L naught. The other is L naught. So which one is L minus L naught? 0.05. Why? Because it's written compressed. يعني make a tension on the of the wire after their length, it will be changed. So that's why it's become elongation, changing length, because we have compressed all time. The numbers comes after compressed is become elongation. So this zero's elongation is equal to, elongation is become 0.05. This one is 0.05 elongation because you have it's written compressed. The other one length, this is 0.4. So divide both, the answer is become 0.125. And because there is no unit, because we say it's unitless, so just divide. That one is elongation because it's written compressed. The other just L naught. Guys, question 2. That question important. Look, question 2. But a metallic wire is under stress. So stress, it's written stress equal to the unit of stress 2 times 10 power 7 Newton per meter square. What force caused the stress? يعني find T. If the area, cross section area, equal to 1.5, يعني area equal to 1.5 millimeter square. So we have stress, it's given stress. Even you have area 2, find tensions. T is easy, you have rule. We have rule. Stress equal to tension over area. How we can find T? T, right, T equal to what? Stress times area. Stress times area. Okay, tension equal to, we have stress. Look, this is stress number 2 times 10 power 7 Newton per meter square times, even you have area 2. Area is 1.5. Baba, because in here, look, it's written by millimeters square. But in here, the stress in the down fraction, you have meters square. So again, it's not same unit. We have to convert this millimeter square to meter square. How? Guys, converting millimeter square to meter square, we have to multiply by 10 power negative 6. So 1.5 multiplied by 10 power negative 6, then it's become meter square. To convert a millimeter square to meter square multiplied by 10 power negative 6. So that one easy. Multiply all together. Multiply all. Multiply all. The last answer T is become 30 Newton. Okay, guys. Last question. Look. A given bronze of wires length 2.5 L equal to L naught 2.5 meter. A cross-sectional area. The area equal to 6.5 times 10 power negative 7 millimeters square. What is the elongation of the wire? What is the elongation of the wire? So it means find L minus L naught equal to what? Elongation of the wire. If it's situation under force, يعني this is T, tension, it's written 10 power 3 Newton. Even Young modulus, it's written 2. Young modulus equal to 2 times 10 power negative 11 Newton per meter square. Okay, Bob, look. We have L naught, we have area, we have Young modulus, we have tension. So now, in that case, we have to use the rule of Young modulus. Young modulus equal to what? T L naught over area L minus L naught. Guys, look. We have all. We have Young modulus, we have L naught, we have T, we have even area. You have to find L minus L naught. Switch the place to find L minus L naught. Switch the place, change the place with the Young modulus. يعني this L minus L naught, it comes instead of the place Young modulus, and the Young modulus, it comes instead of the place elongation. So in here, because we need L minus L naught, write L minus L naught equal. Okay, this Young modulus, it comes instead of the place of the Young modulus. Area, it's left. Young modulus comes here in this place because we are switched with the Young modulus. Young modulus unit parameters comes here, and the L minus L naught goes instead of the place Young modulus. In the up, still you have T, L naught. Okay, L minus L naught equal. T, we have T, it's 10 power 3 Newton. L naught, it's 2.5 meter. 2.5 meter. Area, we have area 6.5 times 10 power negative 7 times, and Young modulus, it's 2 times 10 power negative 11. Guys, in here it isn't necessary. We don't need to convert the unit because look, it's all same unit, meter square, meter, same unit. So we don't need to convert. So guys, now we can easily find L minus L naught. Use calculator. First multiply the up. And this is easy. First 6.5 times 2 become 13. Wait. I don't have calculator now. You can do it by yourself. Look. In the down, 6.5 times 2, I think it's become 13. Negative 7 with negative 11 is become negative 10 power negative 18. The up, 10 power 3 times 2.5 has become 2500. Okay, then divide this number by this one, and 10 power negative 18 move it up. You can use calculator and you get the answer. Guys, today it's enough. Thank you for watching my video. Thanks for all. I hope to get the benefit from my video. This question, actually, I don't remember the last answer because I don't have a calculator now to do it. You can't do it by yourself. Do this calculator all together. You can easily get the answer. Thank you for all. Have a good time.